Okay, let's talk about inverse functions. First of all, what's required to be a function? So if something's a function, f of x, if it's a function, then it has to be, if you pick an x, you only get one value out for f of x. For example, if I have y equals 2x plus 3, if I pick an x like 2, I get 7. If I pick 1, I get 5. I only get one answer out. If, if my f of x was something like plus or minus the square root of 3, or of x, if I put in 4, I get two answers out. This would not be a function. Okay? Now, inverses take whatever the function does to a number, or whatever it takes an input, and whatever comes out, the inverse function, if you input into the inverse function what came out of the original function, you get back to what you originally put in. For example, let's take this one here. If I put in 1 for x, what I get out for f of x, or the y value, if you will, I put in 1, I get 2 times 1 is 2 plus 3, 5. If I put in 2, I get 4 plus 3, 7. If I put in 3, I get 6 plus 3, 9. And I could do a lot more. The function that's the inverse of this will take as an input the outputs of the original one. So if I put in 5, I need to get 1. If I put in 7 into the inverse function, and I haven't put it up here yet, I should get a 2. It works things backwards. It takes a 9 and returns it to a 3. This would be f inverse, and we use a little -1 like an exponent, but it doesn't mean to the -1 power. It means the inverse function. And that's so that -1 seems to have a dual notation meaning, and so you have to be careful on that. If it's on a function, that means this is the function that undoes what the original function did. Now, to figure that out from an equation, we could say, okay, this is the output is normally we call y. We normally call the output y. So if I wrote y equals 2x plus 3, to find the inverse, I want to change the role of the x and y. I want the output to become the input, the x, and the input to become the output. So I do what I call the swap. And so I put x, the output becomes the input, and the input becomes the output. They're swapping roles, or changing roles. And now I solve for y. So I figure out what the output is, how to get the output. So to solve for y here, it's times a 2 and plus a 3, so I subtract 3 from both sides, and I get x minus 3 equals 2y, and then this is times a 2, so I divide by 2, and I get y is equal to x minus 3 over 2. This should be what this is. If I input a 5, it says 5 minus 3, which would be 2, divided by 2, which would be 1. If I put in 7, 7 minus 3 is 4, divided by 2 is 2. If I put in 9, 9 minus 3 is 6, divided by 2 is 3. So it's taking what was the output of the original function and taking it back to the input of the original function. So this would be called the f inverse of x. This undoes what this f did. So that's the inverse of that. And it is a function. If we simplify this, we take divide that by 2, I get 1/2 x minus 3/2. That's a line, just like this is a line. This is just a different line. And a line on a graph is a function. For every input you put in, you'll get a different output. Okay? There's no duplications, like this was not a function. This is. Okay? Now, I could give a function as an equation. I could give you a function that's a table. And I could give you a function that's a graph. Let's do a graph one now. Let's say on my graph I have, so not related to this, let's say this is g of x and it's just a graph of it. Let's say there's a point that's at 2, 1. And it's connected to the point, this is 2, 1, 2, 3, 4, 5. 5, 0. And then it's also, the 2, 1 is connected, let's say, to -3. Let's make it 1, 2, 3, 4, 5, 6. -3, 6. It's connected to there. And let's say at this end, it curves up sort of like a parabola, so it goes through 7, it curves down 7, -4. -1, 2, 3, 4. So what would the inverse look like? Okay. Well, g of x takes a -3 and makes it a 6. So g inverse of x would take a 6 and make it -3. So I plot that point. 6, -3. So this point gets put there. And the point g takes a 2 as an input, gives an output of 1. So g inverse would make 1, take an input of 1, and turn it to a 2. Now these 2 points were connected. So on the inverse, those should be connected also by a straight line. So this becomes this. Now this 2, 1, which became 1, 2, is connected to 5, 0. So the inverse would connect the 1, 2 to 0, 5. 0, 1, 2, 3, 4, 5. So these points end up here if I switch all those. And this last part, 0, 5, is connected this way to 7, -4. So the inverse would take take as an input -4 and give me 7. 5, 6, 7. And since it came off the line, straight off of it, and then curved down, I'd come off of it and curve this way. Is this a function? Well, for any input, I get one output. For 4, I get negative 1-ish. For 3, I get 0. For 2, I get 1. And for 1, I get 2. And for 0, I get 5. And there's only one output for each one. So this is a function. Okay, so there's a graph. Here's a table. Let's do another table. Let's say I had the inputs here and the outputs here, and let's call this h of x. And let's say my inputs were minus 2, minus 1, 0, 1, 2. They're not telling me what's going on with the other points, but I've just got those. And a minus 2, if I put it into h, let's say it came out to be a 4. A minus 1, I put it in h, I get 2. If I put in 0, I get 7. I'm just making up random numbers. I put in 1, I get 2. And I put in 2, I get, let's say, 5. So if I try to do the inverse, just in a table form, the inputs for the inverse are the outputs. So that would be 4, 2, 7, 2, oh, a duplicate. That means I'm putting in 2 and out would come a negative 1. This would be h inverse. And I'm putting in a 2 and I get plus 1. Just to finish, I would have put a 5 and a 2. But this means h inverse is not a function because I put in 2 and I get 2 possible outcomes. So in this table, this would not, h inverse would not be a function. Now, if you were to look at this on a graph, there's something about the graph that tells you it's not a function. If I plot the points negative 2, 4, and then 1, negative 1, 2, and then 0 is at 7, and 1 is 2, and 2 is 5. For every x, there's only one output. Negative 2, there's a 4. At negative 1, there's a 2. At 0, it was, 0 was 7 up there. 1 was 2, and 2 was 5. But if I go the other way, right here you can see that for these originally outputs, the inputs are, there's 2 different inputs. For this input on the inverse, or the outputs on the original one, there was 2 values that were the same. And when that's the case, you're not going to have an inverse function. But let's do a table that is a function. So if, let's say I have another one, let's call it k of x. And let's say I put in minus 2, minus 1, 0, 1, and 2, just simple numbers. And I got out 2, 4, 6, 8, 10. There's no duplicates here. And so the inverse, k inverse, would take as its inputs the 2, 4, 6, 8, 10. The x's are the inputs. And the outputs would be what the inputs were. -2, -1, 0, 1, and 2. And this would be a table showing the inverse of the table form. Okay, now the hardest ones probably are the hardest. Graphing, it's pretty easy just to switch the coordinates to get a picture of the inverse. A table, it's pretty easy just to switch the two rows to get the inverse. But if it's equation, you have to be able to do a little bit of algebra. For instance, let's say it's t of x is a parabola. Well, that would look like this. Well, for this input, there's one output. For specifically, -1 gives you 1, and 1 gives you 1. So we have the point -1, 1, and 1, 1. This is going to be a problem. It won't have an inverse function, so I can't do t inverse. But if I restrict the domain, so let's say I do the domain is the interval from 0 to infinity, then I'm only looking at this half of the parabola. So if that's gone, then the inverse would be a function, because for any y value, any output, I'd only get one input, so this would have an inverse. And its inverse would be, let's see, I take this, I think of this as y equals x squared. I do a swap, and I get x equals y squared, and then I solve for y. Let's see, to get rid of the square, we square root, and it would normally be plus and minus, and that would make it not a function, but since I'm only using this part, I only need to do the plus one, and I get y equals the square root of x. So this function's inverse function on this domain only would be y, or the inverse function, is the square root of x. Let's do, let's say p of x was 4x to the third. Now, you should know that the x to the third looks something like this. And if I multiply it by 4, it stretches it and just makes it look stretched out. But for any x, there's only one y, and then for any y, there's only one x. So this one will have, this one, that's called being 1 to 1. This is 1 to 1. For any x, there's one y, and for any y, there's only one x. For this x, there's this y. For this y, and for this y, there's one x. I could put points in here and figure out what it is, but let's find its inverse. So first, this, we think of this as y equals 4x to the third. We do a variable swap, and we get x equals 4y to the third. And now we solve for y. So we undo backwards. So this is times, and that power, undo the times first, so we divide by 4. And we get y to the third equals x over 4. We undo the cube by doing the cube root, and cube roots you don't do plus or minus, and we get y equals the cube root of x divided by 4, and that's what p inverse of x would be. That would be the inverse. Let's check. If I put 2 in here, 2 to the third is 8 times 4 is 2 makes 32. If I put 2 in here, I get 32. So in the inverse, I should be able to put 32 and get 2. So I'll put 32 into here. 32 divided by 4 is 8. So I'd have the cubed root of 8, which is 2. So I put 32 in and I get 2. See how that's the inverse of this? The points are switched. So that's how I would get the inverse.